Hi again. This is a discussion about the different types of immunity that we have in our body. I know you guys have been looking at this all week, so you're probably familiar with all four of these, but I just wanted to touch on these for a second because they're really important. There are two major types of immunity that we can discuss. One is called naturally acquired, and one is artificially acquired. Artificially just simply means that we're somehow getting an injection, medically speaking, of some particle that's going to help impart immunity into us, and there are a few different ways that we do that. Naturally acquired is going to not involve any type of medical intervention at all, but just something that we are exposed to in a natural way. So we're going to go through all four of these and talk about the differences. The first, active natural immunity. Active means that we are actually stimulating our immune system. We're actually getting our naive lymphocytes in contact with a particular antigen so that they get triggered. Those lymphocytes then divide and produce their clone cells and then produce their antibodies that are going to help us fight off whatever this pathogen is. So active immunity means that we are actually triggering these immune cells. We get memory cells produced as a result of active immunity as well. So if there's a type of passive immunity, we don't stimulate memory cells. So that type of protection would only be short-lived. But anything that's considered active is going to activate these memory cells, which means we're going to have immunity that lasts for our lifetime. So active natural immunity just simply means being exposed to some sort of antigen, some sort of pathogen, like somebody sneezing on you, like drinking after somebody who has another pathogen that's already in their saliva and it gets into your body that way. It might be hanging out with somebody who has chicken pox, right? So these are just the natural exposure to some type of a pathogen, and you naturally get sick as a result. Now, we know that when we're dealing with natural exposure, we have this ramp up of time that it takes to get the antibodies produced. And it typically takes about 7 to 10 days to get these antibodies produced in such a way that it can actually protect our body. So the big key to this is that in this time frame, we actually experience the symptoms of being sick. So active natural immunity, we actually get sick, but we develop the memory cells for the future. The other option is active artificial immunity. So we are actively being exposed to the antigen. However, it's coming in through a vaccination, through an injection. These antigens are usually weakened forms or actually dead or just small pieces of this pathogen. Whether it's the virus, they chop it up into little pieces. Maybe they heat it up really hot and so it actually kills it. But either way, they're taking pieces of these pathogens and injecting them into the body. But because we actually have the real thing, we have the surface antigens that actually trigger our naive immune cells, those lymphocytes, and those naive lymphocytes divide and produce the clones, which give us the antibodies and produce the memory cells. The big issue of why this vaccination option is helpful is that because the antigen that was injected was weakened or dead, we actually don't get sick like we did with the natural exposure, and we still develop the memory cells and the antibodies so that when we get exposed to it naturally in the future, those memory cells kick right in. We ramp up to our antigen production so much faster, so much so that you don't even know that you're sick. So that's why this active artificial immunity is so helpful. Here's another figure that just shows these weakened or dead antigens or pathogens that are included in the vaccine. Our body creates the actual antibodies against it and the memory cells so that when we get exposed to it naturally, we never even know that it's happened. The two other options fall into the category of passive immunity, and we said that this is going to be something where the immunity is imparted to us for a temporary time, but it's not going to create the memory cells. So one great example of passive natural immunity is through breastfeeding. So here, the mom has antibodies that are pre-made because her body, her immune system, has already produced them. But they're small enough to pass through the breast milk to the baby. So for the time that these antibodies circulate in the baby's body, those antibodies function to protect that baby against pathogens that the mom has already been exposed to. So that's a really cool option. And then the last one is called passive artificial immunity. In this type of immunity, because it is passive, remember that's going to mean that we have some type of an injection of some sort. In passive natural immunity, that was when we had the antibodies coming from the mom through the breast milk to the baby. Now we're going to talk about how we get antibodies from another source and inject them into a body when necessary. A great example of this is an antivenom, which is given to protect somebody who has been bitten by a snake. So let me show you how this would work. So you take the snake, you milk the snake, which means that you get the venom out and you collect it. That venom is then injected into some sort of a host animal, a rabbit in this case. A lot of times they use horses because of the large volume of blood that's available. As the venom gets injected into the host, this is going to create the natural exposure of this antigen. The host animal is going to activate those lymphocytes that are naive at the time, but then they get triggered to produce all of the clone cells, which make the antibodies, and then they create memory cells in that host as well. But what we do is that we then take some blood from the host and we pull out the blood, we spin it down, and we get in the plasma portion, that's where you would find all of the antibodies because those are floating around as part of the plasma. So as you spin that blood down, you can pull out the antibodies, and then you can take those antibodies and you put them into the antivenom that you would have as an injection available for a patient. Now the question becomes, why in the world do you need to go to all this trouble to pull the antibodies out of a host and then put them into this injection? Well, the big part is that with particular situations like being bitten by a snake, that 7 to 10 day time period that we talked about where the antibodies would be produced, that would potentially take way too long to protect the body because the person might die way before they were actually able to produce the antibodies needed to prevent the damage that that toxin or that pathogen or that venom is going to create in their body. So in particular situations where this toxin or this pathogen would kill the patient in a very short amount of time, you need to have the antivenom or this anti-serum produced with all the antibodies ready. And what happens is that if you have all of these pathogens in there, let's say these are all of the pieces of the venom, right? Well, they're all going to have active sites on the surface, and these active sites are what bind to your body and start to cause damage that could eventually kill you. But what these antibodies do from this injection is that the antibodies actually bind to these active sites, and in the process they neutralize that venom, and they prevent that venom from actually doing damage in the body, which is going to save the patient, which is wonderful. So in this anti-serum injection, the antibodies are pulled out, and as soon as they're injected in the body, they actually bind to and neutralize or cover up the parts of the antigen that would actually cause damage or death very rapidly. Rabies is another example of this. So if you get bitten by a rabid animal, you would have to go in and get a large anti-serum injection that had the anti-serum for this rabies. And that would go in and neutralize everything that's in your body, and then you would have to get a series of vaccinations that would build up your own natural immunity. So hopefully this helps you understand the 4 types of immunity that we can get, and let me know if you have any questions.